let's talk some more about risk assessment. And we're upping the sophistication here a little bit. The last video where I talked about risk assessment, that was more of an introduction to risk assessment. But in this video, I want to share with you a specific method that takes into consideration the cost of controlling the risks and the hazards that are identified. But before we jump into that, let's take a quick look at this picture here. What we have here is the rebar structure that goes into the foundation for the big windmills that we see in these wind farms out in western Oklahoma, especially in other parts of the country. Just a massive amount of rebar, massive amount of concrete goes into it. And in some designs, they even have the rebar tied to concrete piers that go deep into the ground. This case, it's concrete. It could be steel piers that are driven into the ground also. But this is probably the best option for anchoring the windmills, especially in areas where there's a lot of wind. If you don't do it right, this is what can happen. This is very expensive. And they had the nice foundation, but the foundation is not anchored to anything. And this might work in some environments. And that's what we've got going with this and this. Also, I don't see that it's tied to any piers that are driven deeper into the soil. And this is the best foundation design, especially in high wind conditions. This design should prevent this type of incident. I know that's not strictly speaking a safety matter, that's more of an engineering and design matter, but that's kind of what we've been talking about. We design workplaces to prevent failure. Just like we design a wind farm so that the windmills don't blow over in high winds, preferably. But again, more on risk assessment. And we're going to bring in the element of finance into this discussion of risk assessment. Higher level risk assessments consider the cost of controlling the risk. We conduct a financial analysis to identify what we call the return on investment, ROI. If we invest X dollars in a control, how much money will be saved or earned from the control? Ultimately, the question we're asking, that we're addressing with this approach to risk assessment when we bring in financial considerations, does the control make financial sense? Does it improve profitability? And I've already said in some previous videos, as safety managers, a lot of times we have to go into our bosses and make an argument based on dollars and cents. And that's what we're doing here with this method that I'm going to share with you. As a sidebar, if you can, I encourage you to fit a finance class into your undergraduate training. Take an introduction to finance class. If it's possible, take a couple of finance classes, because you will be able to, or you need to be able to speak the language of dollars and cents as a safety manager. You need to be able to show your supervisors that what you're proposing does make financial sense, that it is cost effective, that it will contribute to the financial well-being of the company. Quantify your argument. Dollars talk, BS walks. They want to hear how what you're doing can save the company money. Show them. The specific method that I'm going to talk about and give you an illustration of here is called the modified fine method. And the risk and cost of protective measures, the modified fine method. And it's all based on an article, Mathematical Evaluations for Controlling Hazards. This method was developed by a man named William Fine. That's why it's the Fine method. And this is the modified Fine method because I've tweaked it a little bit, so it's not strictly the method that was proposed in this article. But for me, it works. It does provide dollars and cents justifications for the proposals that we might make as a safety manager. I said in the last video it's very difficult to find quantitative data or numerical data for our risk assessments. This is a quantitative method where we will use numerical scores that will look at the cost of corrective action versus the level of risk. Does the level of risk justify spending the money on the fix? Does the level of risk justify, put a question mark here, justify spending money on the fix? And that's really what this is all about in this particular method. There are two primary components in this method. But now each component is made up of other components, so it's not just as simple as the two components. But I'll break it all down for you. A risk component divided by the cost justification component will result in a cost justification factor. And depending on the value of that cost justification factor, we can argue that the cost of correcting a safety problem is justified. In some cases, though, we may not be able to argue. Maybe in some cases, the cost is not justified based upon the level of risk. But let's take a look first at the risk component. Again, there's risk component, cost justification component. The risk component equals the consequence multiplied by the exposure multiplied by the probability. Remember in the previous video we talked about risk level being a function of severity or consequences and exposure or severity and probability of an incident occurring. Well, here we combine all three of those variables. To find our risk component, we need values for each of the three variables. The scores are assigned for each of the variables based on observation, experience, and critical judgment. We don't pull out a ruler or pull out a certain type of measurement device to come up with these numbers. It still, in essence, is going back to observation, experience, and critical judgment to identify consequence, exposure, and probability values that we need to find the risk component. Let's talk about how we assign a consequence value first. The consequence value or consequence score is assigned based on the following scheme. If a death could occur, the consequence value receives a 10. Multiple worker injury or illness, not quite as serious but still pretty bad, it receives an 8. Very serious, maybe permanently disabling injury or illness, 6. A serious injury like a broken bone, concussion, lung damage, that's going to receive a 4. Other injury or illness only requiring first aid type of treatment, like a cut, a headache, or a minor sprain, that's going to receive a 2 for its consequence value. Exposure, the exposure value, if they are exposed to a hazard every hour of the day, exposure gets a 10. If they're not exposed every hour of the day, but they are exposed every day, receives an 8. Every week, a 6. Every month, a 4. Once a year, 2. Now the probability score. 100% probability in this strategy means that if they are exposed to the hazard, they will be affected. If they're exposed to the hazard, they will be affected. If it's 100%, the probability receives a 10. If it's 75% chance that they will be affected by the exposure, it's an 8. 50% chance they will be affected by the hazard, by exposure to the hazard, 6. 25% 4, 0% 2. Now 0% is not 0, but it's not assigned a value of 0. It's assigned a value of 2 in this strategy. Okay, that was the risk component. Consequence, exposure, probability. Once we have all of our values, we multiply those together. Consequence, exposure, and probability values multiplied together, multiplied by one another. And you're going to end up with a value ranging from 1 to 1,000. If it falls into the 801 through 1,000 range, that's considered the highest risk possible. 601 through 800, higher risk. 401, 600, high risk, and so on. But the risk component is going to be included in other calculations before we're done. And by the way, I am going to give you a real world example of this. This is just laying out the method first. We talked about the risk component. Now we want to talk about the cost justification component. Again, we're going to use the risk component and the cost justification component to find a cost justification factor. The cost justification component has two dimensions. We're looking at the effectiveness of the fix and the cost of any corrective actions. And when I use the term fix, we're talking about corrective actions or controls that we're implementing to control the hazards in the workplace. Again, I will use the term fix as a shortcut. That's what we're doing. We're fixing the problem. Now, the effectiveness of the fix, we need a value for that. If our corrective measure completely eliminates the hazard, it's 100% effective, we're going to put a 10 here in our formula. If it's likely to control the hazard, if we think it's 75% effective, we're going to assign an 8. 50% effective, 6. 25%, it has some effectiveness, but it's kind of marginal, 4. If it's less than 25% effective, it's going to receive a 2. And keep in mind, these are judgments. This is based on critical thinking, and it should be some collaboration involved. Ideally, it's not going to be one person that's using this method and working on this method and coming up with the values for these different components. The cost of corrective actions, if the cost is greater than $100,000, it receives a 2. Now, and this scale is reversed. Higher cost, lower value. Greater than $100,000, it receives a value of 2. $50,000 to $99,999, 4, all the way down to a cost of say of $0 to $999. That's going to receive a cost of corrective action value of 10. Once we have our effectiveness value and our corrective action value, we can multiply those together, and that's going to give us a cost justification score. And again, this isn't the end result, but you could use this in your proposals, in your arguments to management by itself. You want to go further than that. You're going to want to look at the cost justification factor. This is when you consider the cost component in relation to the risk component. And you arrive at that cost justification factor by dividing the risk component value by the cost component value. Cost justification factors 10 or greater, generally speaking, will justify the corrective action. And let's look at an example of the FIND method, and again, modified FIND method. I guess I didn't really need to write all of that out. But let's say we have a poultry processing company that's experienced a serious problem with slips and trips at their Siloam Springs, Arkansas facility. We can calculate the risk score. We can calculate the cost of resurfacing the walking surfaces with a material called Tough Coat. Tough Coat can be used on slippery surfaces to make those surfaces less slippery. Once we have that information, we can calculate the cost justification score and the cost justification factor to determine if covering the surfaces with tough coat is justified. Here's our scenario. Multiple workers have already been injured. What would be the consequence value? The facilities had 26 recordable slip trip injuries in the last 8 months. We have multiple workers injured. Consequence value equals 8. That's the value that I'm going to assign to the consequence. That's just in an 8-month period. If you project that out over a 12-month period, I think I've got it calculated on another slide. I think it's 39 injuries each year at this rate. So we have our consequence value 8 for the risk component. Again, because we have multiple workers injured, that's why we're giving it an 8 for consequence. Exposure value. Workers are exposed to this hazard every day. Maybe not every hour of the day, but every day. So the exposure value is going to be 8. We haven't had an 8 for consequence, now we have an 8 for exposure. Based on recent experience, it's determined that workers are likely to be affected. Likely to be affected, we're going to give that an 8 also. That's going to receive an assigned value of 8. 75% likely to be affected. So we have 8, 8, 8. That's going to make up our risk component. Multiply everything out. Our risk component is 512. This would be considered a high risk circumstance. Something that we definitely need to consider corrective actions. We need to consider doing something to prevent these types of incidents from occurring. Now we look at the cost justification component. We need to determine what the fix is going to be and the cost of the fix. Now some areas of the facility, let's assume that some areas are already covered in tough coat. And here's what we're talking about with this tough coat material. It's a material developed for marine applications. It's effective on most surfaces, including concrete. It goes on kind of like paint. You can roll it on. You can also be sprayed on. But one thing they've noticed, again, some areas of the poultry processing facility are already covered in tough coat. Injuries are occurring in areas not having the surfacing. They're not having the slips and trips and the injuries in areas where there is tough coat. It's only areas where there's not any tough coat. Safety managers are recommending the application of tough coat on all walkways. They already have some evidence that tough coat will be fairly effective in preventing these types of incidents. Do some calculations as far as the cost of the tough coat application. The surface area, let's say it's 6,000 square feet of walking surfaces that need to be coated. We identify the materials that we need. 114 gallons of tough coat at $104 a gallon, $11,856. You also need to put down a primer coat prior to putting down the tough coat. You'll need 25 gallons of primer at $81 a gallon. You're going to roll it on. 14 roller pads at $18 a pad, $252. Roller handles, $12 a handle. So our cost of materials to surface 6,000 square feet with the tough coat slip prevention material is $14,193. So pretty good chunk of change for any company. But that's not the only cost. We also have to consider the labor cost. We have 4 workers spending 8 hours a day for 4 days. and we consider the labor cost per hour at $42 per hour. Now that's not what we're paying the workers, but that's the total cost of the worker when you take into consideration the benefits that the company pays on behalf of the worker and the taxes the company pays on behalf of the worker. So 4 workers, 8 hours a day for 4 days at $42 an hour, $5,376 on labor. There will not be any lost production because of this application process. We're going to apply the material at night, and we're going to coordinate the operation so it's not going to interfere with production. If we did have lost production, if we had to shut down part of the plant for this corrective measure, then that's going to add to the cost. So, but we're going to assume, for the sake of this example, that there's no lost production. Our only costs are the cost of the materials and the cost of the labor, about $20,000, $19,569. Now, one other consideration that I need to mention: this is an in-house job performed by maintenance personnel. A better option might be to subcontract this out. If we hire a subcontractor to come in and put down the tough coat slip prevention material, that might actually be more cost effective. We would want to explore that. But for the sake of this example, this is an in-house project. That's going to cost about $20,000. Another consideration to make, and you got to think about all the angles. And again, I'm really not thinking about all the angles. I'm just doing a quick and dirty example of how you can use this method. But another thing that you would need to think about that could result in lost production. You put this material down, it has a cure time. It has to have time to dry. What if the cure time is longer than you anticipated and it does cut into production? If cure time takes longer than you anticipated and it does interfere with production, that's going to be an added cost also. But again, for our purposes, we're just going to go with $19,569 as our cost for the fix, for the corrective action. Based on recent experience, and that recent experience would be that area of the plant that does have tough coat already. Remember, those areas that already have the tough coat down, they don't have slips and trips. So based on that experience, we're going to estimate that the fix will be 75% effective. 75% effective receives a value of 8 for the effectiveness of the fix. Again, this is the cost justification component. We've done the risk component, now we're doing the cost component. And for the effectiveness part of the cost justification component, we're going to give it a value of 8 because we estimate that it will be pretty effective, 75% effective. Now we look at the cost, which we've already calculated. The cost of the corrective action is right around $20,000. That's going to result in a value of 6 for the cost portion of the cost justification. So we have 8 for the effectiveness of fix and 6 for the cost of the corrective action. Plug in these values and multiply. We end up with a cost justification value of 48, which falls into the fixed range on this scale. According to the fine method, the cost of the fix is justified. Now, we can also look at the cost justification factor, which is the risk component divided by the cost justification component. Our risk component was 512. Our cost justification component is 48. We do that division, we end up with a justification factor of 10.7. And generally speaking, a justification factor greater than 10 justifies the corrective action, the cost of the corrective action. But again, that is the fine method. Let's look at cost justification from another angle. without using the fine method. Okay. The average cost of a slip or trip recordable injury at the Siloam Springs plant is $9,200. There were 26 recordable injuries due to slips and trips in the last 8 months, which we've already mentioned. 26, this projects out to 39 slip trip injuries per year. If Tough Coat is 75% effective, we take 39, multiply it times 0.75, the effectiveness. We're going to end up with a reduction of about 29 slip trip incidents per year. We're going to prevent 29 injuries per year. And 29 injuries will save 29 multiplied by the $9,200 cost of an injury can save $266,000 a year. And let's compare that to the cost of Tough Coat. Let's say we have to recoat the plant every year. And it's $20,000 every year. Does it make sense to put down the Tough Coat? If it can save over $200,000 a year at a cost of $20,000 per year, with a net savings of approximately $250,000 per year, it makes sense. These are the kinds of financial arguments that you need to be able to make sometimes as a safety manager. Whether you're using the fine method or whether you're using this more straightforward cost justification approach. So, hey, we've had this many injuries and it's cost us this much money. If we can use something like the Tough Coat corrective action that can prevent injuries, is that going to save us money? Is it going to make the company money? Another caveat to this, this example is based on a small area. If the area is larger, the cost is going to be greater. But still, even let's say we double the area. Let's say it's $40,000 per year. If it's saving $250,000 plus per year, you could argue that it's justifiable to invest in this particular corrective action. Okay, a few more things that I want to mention with regard to financial analysis of prevention measures, and how, again, we're talking about how financial analysis relates to risk assessment and the implementation of controls. Again, when I say a few more things, I'm talking about a few more tips that I want to share with you. If you're a safety manager and you're making proposals like the one that I used in the illustration, try to get on the good side of the financial experts within your company, the chief financial officer, the head of the accounting department. Get those individuals involved in your analysis. Get them to support your proposal. That's going to add credibility to your proposal. So involve the financial experts. Also, you want to obtain detailed cost estimates and show management that you've considered different alternatives. If you just go in with one proposal or one alternative, they're going to probably tell you go back and do your homework. Consider several different options, not just for the fixes, but also for how you're going to accomplish those fixes, how you're going to pay for those fixes. Are you going to subcontract it out? Is it going to be done in-house? Provide the cost of each of those different approaches. So, again, the more ammunition you have from a detailed analysis, the better your chances are going to be for successfully persuading management. And that's really what this is all about, persuading management to pay for the implementation of control measures that are important for the safety of workers. And the examples I gave you are quick and dirty. If I can talk about it in less than an hour, it's not real detailed. We need to be much more thorough than the example. The main takeaway I hope you get from this video is that we need to be able to do financial analysis to some degree. We need to talk in the language of dollars and cents with management, and take, like I said before, take a finance class. That can help us a lot as safety professionals. Another consideration, and this is getting, I don't want to get into the concept of time value of money, but consider time value of money, interest rates, present values versus future values. That's what we're getting into with the time value of money. And that's where, again, the financial experts can come into play to help us. Talk about the return on investment. Be able to show management how, you're going to invest $100,000, but here's what we're going to get back out of it. Be able to quantify that. And if you're not comfortable doing that, going back to my first point, get your financial experts involved. The first company I worked at, a small company, to get anything done, I found that the best way to do it was to go through the CFO. It was a small enough company. The CFO and I were basically on the same level. If I had an idea, I would go, I'm not going to mention his name, I'd go, so-and-so, I really think this would help our company, and here's why I think it would help, and here's the savings we would have, and I would lay out my financial argument to him, and he would, he might critique it, he might provide suggestions, but generally speaking, he would end up being on my side, and we would take our proposal to the ownership of the company. And 90% of the time, our proposals were approved with good, solid financial analysis. And again, most of that is because, I'll have to admit, it's not because of me necessarily and my financial analysis skills, but getting those financial experts involved. All right, that is it for this video. If you have any questions, let me know. And I will see you in the next video.